Okay, we are now on air. We're live.
Perfect. Okay.
So, I guess we're pretty much doing the same thing that we did last time. We just have that quiz at the end we need to take.
Right.
Or do so. Discuss and make sure each team member understands the 5 different transformations and the 5 important points for transforming the sine and cosine function in graphs.
Okay. So, are you here?
Just a second, Tucker.
Okay, no problem.
Okay, sorry about that. My sisters were calling me.
Okay, no problem. What page are you looking at here?
It's the week 2, lesson 3 and 4 instructions for.
Oh, I am week 2. I am on the wrong week.
Are you on week 3?
Yeah, I clicked week 3 on accident. I wondered why everything looked way different than I.
Yeah, no, you're fine.
Okay, so we're on week 2, due date 2, right? Lessons 3 and 4.
So for the equation, the A sine in parentheses B, the X minus C plus D thing.
Mm-hmm.
Were you able to figure out what the A, B, C, and D
So the 5
are?
Transformations and 5 important points using for transforming the sine and cosine graph. So let me find it again here in the textbook. The transformations. So, okay, transformations of sine and cosine. I know it's just like the graphs we talked about, like in the algebra review.
Yeah.
Essentially, all the transformations are either going to stretch the graph or like compress the graph or just move it along the coordinate plane. So there's, and what is the 5 important points used for transforming the sine and cosine graph. So the first one is amplitude, right?
The A, yeah, because that's the vertical stretch up and down.
Right.
And if it's negative, then it's reflected.
Right. And so that one just raises like the minimum and the maximum points of the graph, right? So like y equals sine x is the maximum and minimum values of that one are 1 and -1. But if it was 2 sine x, the max would be 2 and -2 and so forth.
Okay.
Okay. The next one is the phase shift. And is that the horizontal movement?
Yeah.
Okay. And that one's C, right? Like plus or minus C.
So the horizontal stretch?
Yeah. Or the horizontal translation. The movement.
That one's for, are you talking about letter B?
Oh, hold on. What am I talking about?
That one's for B. And I found the equation to figure out the period for the whole, like, up and down. It's like 2 times pi over whatever B is. So if it's like half, then obviously it would be, I think, pi. So that means that the whole thing would have to fit in pi. Like the whole period is in pi.
Okay.
Does that kind of make sense?
I think so.
Normal one is, the whole period is 2 pi. That's
right.
what the period is for just the normal one. So if you were to just do half that, it would be stuck within just pi. So it would go up, like it would fit just in pi, which is what the horizontal stretch does. Either stretches it out or it brings it in. And to figure out what period it fits in, you just do the 2 pi over whatever b is.
Okay, so you're still talking about the stretch, right? Not the shift.
Yeah, the horizontal stretch, yeah. Because we already talked about the vertical one.
I think I was talking about the vertical one when I was talking about amplitude.
Yeah. Okay. Because I know, because C and D are the moving.
Yeah. Okay, that's where I got confused.
Okay.
All right. Yeah, I think I've got that.
Okay. And we know what C and D is.
Yeah, that's the horizontal and the vertical movement, like translation.
Yeah.
Okay.
And with C, if it's negative, that means you move it right. Yep. On the graph, and positive, you move it left because it's opposite or whatever.
Yep.
Cool. And the 5 important points, those are just like the 0, 1, pi, and so on and so forth, right?
Yeah, I think so.
Okay. But for cosine, doesn't that one? Okay, I just wanted to make sure that one was the one that started at 1.
Cosine?
Yeah.
Yes. Because yeah, I can't remember why, but I think you're right. Well, let me look at the textbook.
Okay.
The graphs.
I was like, I'm pretty sure that's what it is.
First coordinate of the terminal point on the unit circle for an arc length of x is shown in figure 537. The arc length x increases from 0 to 2 pi. The first coordinate of the endpoint increases from 0. Some ordered pairs that satisfy y equals cosine x. So the first coordinate decreases from 0 to -1. As the length increases from pi to 2 pi, the first coordinate increases from -1 to 1. The graph of y equals cosine x has exactly the same shape as the graph of sine. If the graph of y equals sine x is shifted a distance of pi over 2 to the left, the graphs would coincide. Yeah, so it's you move the graph over pi over 2, and that's your cosine graph. And that would start, yeah, so the sine graph goes through 0.00, and the cosine and the parent graph does, and then the cosine graph goes, it skips that and it goes 0, 1, if that makes sense.
Yeah, so it starts up awkwardly at the 1 instead of the 0.
Yeah.
And it goes down to pi over 2, and then goes down -1 pi.
Yep.
Okay, good. I just want to make sure that I had gotten that.
Okay.
So when it says the 4 additional trig functions, are those the CSC and?
Yeah, so I think the other 4, so you have sine and cosine, and the other 4 are tangent, cosecant, secant, and cotangent.
Okay. Yeah, those ones. Did you in the textbook? Does it tell you how to graph those ones?
No, I haven't read anything about graphing those ones yet. I don't.
Okay, because I know it's in the quiz.
Oh, maybe
yes.
Maybe I just.
Because I know, like, I don't know about you, but in the last lesson, like 1 and 2, I was able to learn like how they're related, but I don't know how to apply that to. Well, I guess it wouldn't be too hard because if like, okay, so like if sine, because just for example, like CSC is 1 over sine, right?
Yes.
Okay, so that makes sense. So if sine is 0 at, well, actually let's go. Sine is 1 at pi over 2. Then at pi over 2, CSC would just be the 1 over, well, I guess it'd be 1 over 1, which is 1, right? Because it's just 1 over whatever sine is.
Say that again.
So I'm just using CSC as an example. So to find the answer for CSC, it's equal to 1 over sine pi, or sine that weird circle thing.
Theta.
So, yeah, theta. Yeah, okay, yeah. So
CSC. I think it's actually
theta. CSC is equal to 1 over sine. So if sine at pi over 2 is equal to 1, then CSC at pi over 2 would be equal to 1 over sine, which is 1, right? So it'd be 1 over 1, which is equal to.
Okay, so you're saying sine of pi over 2 is 1, right?
Yeah.
So then if cosecant is 1 over sine, it would be 1, I believe. So yeah, you're right. Let me check that on my calculator real quick.
So, okay. And so if sine is 0, then CSC would be 1 over 0, which is undefined. I don't know how you would graph that if we're calculating it correctly so far. I guess.
Oh, there's a domain error. What does that mean?
Oh. Those graphs look funny. They don't look like the
section. So I think you're right. I think it is undefined, the cosecant of pi over 2, because it doesn't give me an answer in my calculator. So equals pi over 2 over 1.
Here, I just put a link in the chat thing. So this graph kind of just shows what it would look like with the undefined in the 1. It's super weird.
Okay. Let me look at it. So I know section 5.4 of the textbook I just found is all about the other functions and their graphs.
Okay, which one is it? 5.4.
5.4.
5.4. Okay, you know what? I'm going to pull that up because that will be very helpful.
So here, I'll just start reading this and see if it helps make sense of it. So it says the tangent, cotangent, secant, and cosecant functions are all defined in terms of the unit circle. We use the abbreviation TAN for tangent, COT for cotangent, SEC for secant, and CSC for cosecant. As usual, we may think of alpha as an angle, the measure of an angle in degrees, the measure of an angle in radians, or a real number. Since alpha equals y, or sine of alpha equals y and cosine of alpha equals x, we can rewrite the definitions of tangent, cotangent, secant, and cosecant functions to get the following identities for these 4 functions. So it's just talking about, it has those little boxes. Have you got it opened up?
I just opened up the ebook. Do you know what page that's on?
It is on page 379.
379. That'd just be easier. Okay, I do have it opened up now. Okay. Yes. Oh. Huh.
So says there, so let me just write these down in my notes here. So the tangent of alpha equals y over x. The cotangent of alpha equals x over y. The secant of alpha equals 1 over x. And then the cosecant of alpha equals 1 over y. And then that's if alpha is an angle in a standard position, so like xy. and it's the point of intersection of the terminal side and the unit circle. If it's an angle or a real number, alpha, then that would make tangent of alpha equals sine of alpha over the cosine of alpha. Do you see these boxes?
Yeah. Okay. And this actually totally makes sense because, like, on the unit circle, x is cosine and the y is sine. So it totally makes sense because, like, the tangent a equals y over x is pretty much the same thing as sine a over cosine a.
Yeah.
That, okay, yeah, no, that completely makes sense. Okay, perfect, awesome. Oh.
Okay, so yeah, you had it right pretty much when you were talking about it before. It says the domain of the tangent and secant functions is the set of angles except those for which cosine of alpha equals 0. The only points on the unit circle where the first coordinate is 0 are 0, 1, and 1, 0, negative 1. Angles such as pi over 2, 3 pi over 2, 5 pi over 2, and so on have terminal sides through either 0, 1, or 0 to negative 0, negative 1. These angles are of the form pi over 2 plus k pi, where k is any integer. So the domain of tangent and secant is alpha does not equal pi over 2 plus k pi, where k is an integer. Okay. Okay, so
okay.
Let me go back to...
I guess that makes sense, right?
Yeah, I think so. So those are the relationships between the two of them. Okay, next we need number 6 from the preparation guide. Practice with the unit circle involving all 6 trigonometric values. Did you do the preparation questions?
Okay. Oh, review the answers to question number 6 from the prep and ensure each member has the correct answers. If any answer is incorrect, spend some. Okay. What is? Let me pull up that prep. I know I went through it. I just don't remember what it is.
Yeah, I didn't really do the questions. I just kind of looked at it.
Yeah. I don't. Yeah, I don't like. Oh, this is actually. You know, we have like that understanding the unit circle kind of quiz that we have at the very end of this unit.
Right.
This is the quiz.
Oh, really?
Yeah.
Oh, did you do the quiz already?
Yeah.
Nice.
So finding these is kind of like what we just read about. So like for COS, that's related to sine, right? So you find sine of 11 pi over 6, and then you just do 1 over whatever that is, and that's what COS is.
Okay, so walk me through that for the first problem. So sine negative 4 pi over 3.
Okay.
So it said, so you need to find, I guess maybe I don't understand what exactly it's asking me to find here.
Okay. They're just wanting to know what the actual number is, you know, like the square root of 3 over 2. That's what they want you to find. So I know we did some of this last meeting. So remember how we found, like, okay, so pi over 3 is 60 degrees. And since it's negative, you're going to go back 60 degrees 4 times.
Right.
And then whatever you land on, that is what sine is. Like, that is the answer for this one.
Right. So, okay, so negative pi over 3 is where you start?
So first what I do is I find like the small, so like 4 pi over 3, it's just 4 of pi's over 3, right?
Right.
So I just find pi over 3. That's just 60 degrees. Okay, so we need 4 of those. And we need to go backwards because it's a negative.
Right.
So I start at
minus 240.
Yeah. Is it? Yeah, because that's what 60 times 4 is, right? Yeah.
Yeah.
So yeah, whatever that is. So you go backwards.
Oops.
240 degrees.
So
like
that's negative 180 degrees, which means, and we're looking for sine, right? So the sine of that is 0.
Wait, so I don't know. I know I did this, but so 60 times 4 is 240. So you go back by 240.
Right. So sine of negative 180 is that?
So what the easiest way that I do is like I do like 360 times like minus 240, which is
120.
120, right?
Yeah.
Okay. So what I do is then I take that. I'm like, okay. So if I go backwards by 240, then I know it's going to be 120 degrees away from 360.
Right.
So that would mean it's at 120 degrees, which would mean that sine is the square root of 3 over 2.
Hold on. I am confused.
Okay.
Sine is the square root of 3 over 2.
Mm-hmm.
So walk me through how you did that again.
Okay.
So, well, let me just explain how I got there. So I started, negative 4 pi over 3, right? So you start at pi over 3, and you need that 4 times. That 60 degrees times 4 is 240. You need to go, because it's negative, you need to go backwards 240 degrees, right?
Yeah, but I start at the, so you don't really, so when I say like start with pi over 3, I mean like just check to see what the degree is for that.
You don't start there, obviously.
But then you start at the 0.
Right.
Uh-huh.
Okay, so 360 minus 240, 120, which gives you negative. Well, and would it be, because you're going the other way negatively, is it negative square root of 3 over 2?
So technically, wherever you land, like even if it's a positive, it'll be a square root of 3 over 2.
Okay.
The only reason why we would go backwards is because of the negative 4 pi over 3.
Oh,
but
okay.
whatever you land on, though, whether it's positive or
okay, gotcha.
negative, that's what it will be.
Yeah, I had that all messed up. Okay, so the answer is negative, or sorry, square root of 3 over 2. Okay, let me take a crack at the other one then. So, as far as tangent goes, oh, whoa, what happened? So tangent of 7 pi over 4. Actually, let me practice with the cosine one first. Cosine 11 pi over 6. And go to the unit circle. Pi over 6 is 30 degrees times 11 is 330. Is that right?
30 degrees times 11
is 330. So then you're going forward. Well, 330 degrees is, the cosine is square root of 3 over 2, right?
Yeah, that's perfect.
Okay, perfect. So with the other functions, so with tangent, for example, that's the sine divided by the cosine.
Yeah.
Correct?
Mm-hmm.
Okay. So then with 7 pi over 4, so pi over 4 is 45 degrees.
Well, 7 pi over 4 is on the unit circle, by the way.
Is what?
Is actually one of the...
That's right.
Yeah.
So 300.
That makes it a little bit easier.
So 315 degrees. And so it's, what did I say? Sine divided by cosine, yeah?
Yeah.
So that makes it the square root of, the negative square root of 2 over 2 divided by the square root of 2 over 2, which is negative 1.
I don't know, actually. Let me calculate that out. All I know is how to do it like, so you do the, so it's negative square root of 2 over 2 divided by square root of 2 over 2. Then I switch it so it's negative square root of 2 over 2 times 2 over square root of 2.
Yeah, and they should cancel out and it makes -1. In fact,
Yep, that's correct.
So when I put my when I put it into the calculator, the tangent of 7 pi over 4, it's -1. So that is correct.
Solid. Awesome.
Cool. So are we supposed to go through each one of these?
If you want to. I just know that we have to at least make sure that we know how to do them.
Oh, well.
Like if you want to, we totally can.
Let's go through just a couple more to make sure that I've got it. So let's do the next one. Cotangent of pi over 3. So the pi over 3, 60, and cotangent is cosine divided by sine.
Yeah,
so that's 1/2.
And it's 1 over all of that. It's like 1 over tangent.
Whoa, hold on here.
Okay.
1 over tangent?
Yeah, so COT, you say it correctly, I don't. The COT equals 1 over tangent. The CSC is 1 over sine.
Right.
And the SEC, no, the sec is 1 over cosine.
Right.
So yeah, you would do like the whole sine over cosine thing, and then you put 1 over whatever you get with that. And then
1 over that?
Yeah, because 1 over tangent. So once you find tangent, you put 1 over tangent to get the answer for COT.
Okay, Okay, so the tangent of pi over 3 would be let me see here. Tangent of pi over 3 is obscure number. Let's see. Pi over 3. And that is sine over cosine. So 1/2 divided by square root of 3 over 2. By square root of 3 over 2, which makes 2 over 2 square root.
Are you doing the sine over cosine?
Sine over cosine. Cosine over sine. No, sine over cosine, which makes it, yeah, I did it backwards.
It's okay. I was like, wait.
Divided by 1/2. So it's 2 times the square root of 3 over 2. And I believe the 2's cancel out, which leaves you just with the square root of 3, right?
Yeah.
Which makes cotangent of that 1 over the square root of 3.
Yep.
Okay. And let me just try it the other way real quick to see if it's the same. Just if I did cosine over sine. If I did cosine over sine, that is 1/2 divided by the square root of 3 over 2, which is 2 over 2 times the square root of 3, and then the 2's cancel out and you're left with 1 over the square root of 3. Okay, so both of the ways that we had it done were right, where you just did the tangent. But if you just flip it and instead of doing sine over cosine, you do cosine over sine, you end up with the final answer.
Weird. I did not know that.
Yeah. So that's what happened here with my problems anyways. We can, here, let's do the other cotangent one and see. So it's cotangent.
Okay.
Pi over 6. And I said, oh man, I can't keep it all straight. Cosine over sine. So cotangent.
And then I'll do it the other way.
Okay. Okay, I got mine.
Sorry, I think okay, screwed. Did you just get like the square root of 3?
I did, yeah.
Okay. Okay. Yeah. I guess that's super cool. Yeah. I guess if you just do the cosine over the sine, for CS was COS, right? Or no,
cotangent, COT.
Yeah. If you do it that way, you just get the final answer. Because if you do the 1 over tangent, it's just like one extra step, which is to put the 1 over.
Yeah.
But if you do it the cosine over sine, you just simply get it without even needing to do the 1 over whatever it is.
Okay. So let's do one more of each of secant and cosecant.
Okay.
And let's just do the secant of 4 pi over 3, and then we'll compare our answers.
Okay. Secant. You said it was, oh, okay. Oh, so you you say the real thing, so I'm like, wait, what's secant?
Okay. I finished.
Same.
Okay, I got -2.
I got +2.
Oh, hold on.
Okay.
So the degrees for 4 pi over 3 is 240. Well, I guess you don't even need to know that. Sorry. The cosine, because with secant, it's 1 over the cosine. And the cosine there is -1/2. So I did 1 divided by -1/2, and I got -2.
So you just like, did you just use your calculator for that?
No, that's the one I did just on the paper. I just looked at the circle and plugged in the values there for the coordinates. Let me do it on my calculator real quick and see if I get the same thing.
Okay. Because it's like when I do the like 1 divided by -1/2, I do the thing where it's like 1 times 2 over 1, you know, where you flip it. I know when you flip it, you have to like make it into a, I don't know, you have to like make it into a positive, unless the calculator says it's -2, then.
Well, my calculator says there's a domain error, so maybe that doesn't work. Hold on, there are some rules about why that doesn't work. The domain of the tangent and secant functions is the set of angles except those for which cosine of alpha equals 0. The only points on the unit circle where the first coordinate is 0 are 0, 1, and 0, -1. Angles such as pi over 2, 3 pi over 2, 5 pi over 2. And none of those are 0. It's really weird. Yeah, let me find out.
At least, the only reason why I did the turned the -1/2 into a +2 over 1 is because there's like that rule of if you move the fraction the division of a fraction into a positive, you have to change the negative to a positive, but I'm not sure, so I will.
Oh, hold on. You're right. What is that rule?
Yeah, I don't know like
Is
what
it
it's
dividing by a negative fraction? Then when you flip it, it becomes positive.
yeah. So like 1 divided by -1/2. If you want to make that 1 times, you just do 1 times, you flip it, so it's 2/1, and then you make it into a positive.
Gotcha. Oh, you're probably right. That is how it's done. But either way, though, my calculator said that there is a domain error.
Same. Mine said syntax error. I was like, I don't know.
Which must mean that, I don't know, it's just not on the graph. Those points are undefined. Which is weird, though, because that's not where the cosine of that number is 0.
I wonder if maybe our calculators suck, or maybe it's because they're in radian.
I don't know. Let me try with the degrees here.
Yeah, would that change anything?
We'll find out. Oh, shoot. With the degrees, it's also undefined.
It's super weird because you're right. It's not a 0, so I don't know why it would be. I'm sure that the okay. So the nice thing about the unit circle quiz thing is you can take it as many times as you need to.
Oh, really?
Yeah. So I guess while taking that, because I honestly can't say I remember what happened with that one. But while you're taking it, I guess you can put undefined and see.
Okay.
Says it's right or not.
That's what I'll do. I'll try and find out then if that's just weird because it works out when I do the math by hand, but not on my calculator.
So, I do not understand that.
Okay, well, let's just try one more. Let's do a cosecant one. Let's just do cosecant of 2 pi.
Okay. That's the COS, right? Yes. Right.
Cosecant is CSC.
CSE, right, because cosine is CS. You know what? Okay. Okay, cosecant 2 pi. And cosecant is just 1/sine and 2 pi. Sine is 0. I think that one is undefined. Right?
2 pi. The sine is 0, and it's 1/sine of alpha, so it is undefined. You're right.
Hey, we found an undefined one.
Woohoo! Finally. All right.
No.
Perfect. All right. Well, I think we got those ones all good.
Cool. So with the quiz. So now we have to graph, right?
Yeah, so let me find the quiz here. We can look at it. Do you want to write it up and send in a picture? Do you want me to?
I can totally write it up. For the instructions for the Google Hangout on Air, it has those extension problems. Did you want to do those, or do you just want to go to the quiz?
Yeah, it's a good idea. Let's try and do 1 or 2 of those.
Okay, because it has two, as a sine and a cosine, just graph. So we can try graphing and trying that out. And now at least we know it's number 2. I know we talked about the parent graph of like the tangent, COT, SEC, CSC.
Right.
But yeah, we can definitely try graphing those because I know we have to on the quiz. Yes, we have to graph. Oh wait. Oh. That's interesting. For the quiz, we have to look at a graph and say what the transformations were.
Oh, interesting. Okay.
Yeah. Anyway, but yeah, I guess we can graph this real quick, the sine and the cosine.
Okay. So for that first one, f of x equals 1/2 of sine of 2x minus pi minus 1. So the 1/2 makes the amplitude of the graph 1/2, which means, so sine passes through 0, right? That's what we talked about.
Yeah.
And it only goes up to 1/2, and it only comes down to negative 1/2. The whole way. So it's what am I talking about? Shrunk?
Yeah.
Just whatever.
Shrunk. Yeah, that's the right word. That sounds good.
Yeah. Okay. And then graphing the sine function. The period is just pi, right? Like always.
Yeah, because, well, the period is technically 2 pi, because half of it goes up and then meets at pi and then goes down and meets back at 2 pi. But with the 2x, the b is 2, right? So to find the period, it'd be 2 pi over 2, which means that the period for at least this one is pi. So it would be in a pi.
Say that again.
You lost. Oh, okay, sorry. So, so for any regular sine parent graph, the period is 2 pi.
Right.
So you remember how I told you earlier that B tells you the horizontal stretch, right? Like how long or how condensed it is. So what B tells you is what the period is going to be. Like gotcha. Like, you know how it goes up and then down and comes back and meets in the middle again?
Yeah.
At 2 pi. So this 2 makes it so instead of going up and down and meeting at 2 pi, you go up and down and meet at pi. So it, instead of like making it short, it shrinks it like widthwise. Does that
horizontal shrink as opposed to a vertical shrink?
Yeah, because you got the vertical shrink when it goes up to half. Now it'll go up and down and meet back at pi.
Pi and not 2 pi.
Yeah.
Okay.
That's what that will do, which is really interesting because with the minus pi, then it moves right pi, which wouldn't really make that much of a difference because if you continue the graph, it'll just be in that same area anyway.
Right.
But I guess if you're graphing just that one section, that would make sense because then it would be from pi, up, down, meet at 2 pi.
Okay. So, okay, so the bigger the coefficient there, the b coefficient, which is this 2 in this particular function, right?
Yeah.
So the bigger it is, the smaller the period, right?
Yeah. Mm-hmm.
Okay. And so if it was a 3, I don't know what that makes the period. Is it?
So it'd be 1/3 of the 2 pi, which is like super small, well, at least smaller.
So 1/3 of the, okay.
Yeah, because it'd be the 2 pi over 3.
2 pi over 3?
Mm-hmm. Oh, yeah, 2 pi over 3 because
1/3 of 360 is 120.
Oh, solid. So it'd be, yeah, it would be, well, yeah, it'd be 120, which, what is that pi-wise? 2 pi over 3. Yeah. Yeah, so it would be at right, it would go up, down, and meet a little bit past pi over 2.
Right. Okay. Cool. And then the minus pi means that it shifts to the right pi.
Mm-hmm.
And then the -1 means it goes down 1 unit.
Mm-hmm.
Okay. Okay, easy enough. Let me try and graph this one then.
The top would be at -1/2, right?
Sorry?
So since it goes down 1, you know how it shrunk to like 1/2, the negative half is the range.
Uh-huh.
So if it were to go down 1, it would, like, the top of it would be at -1/2, right?
If it were to shift down 1, yes, I believe that is correct. So here, let me graph this, and I'll show you and see if I can get the same thing as you. So go through.
Okay, I'm gonna try graphing this.
Alrighty. So, did you get it?
Yeah.
Okay, so let's see if you can see this on my little notebook here. Can you see that very well?
I think so. I can't talk, or it goes to my face. Let me click on that again. Yeah, let me see if I got the same thing. Pi.
And each unit there is pi over 2 going to the right or left, and then it's just 1 up and down.
-1/2. So I have one question about your graph.
Okay.
Because we almost have the same. Well, we almost have the same thing. So for the so at pi, you have yours at -1/2, right?
The amplitude?
Like the point for pi. Does that mean at -1/2?
So 0, or sorry, pi 0 at that point? Or sorry.
Yeah, pi 0. Yeah, so just like at pi, the point all the way down, that is, you have yours at -1/2, right?
-1/2. At pi, it's actually at -1 because, let me look at the problem here. Because the last coefficient here, -1, means it shifts down 1, right, on the graph?
Yeah.
Which means that it starts at -1 at that line that goes through -1, 0. That's like the middle line. And then the minus pi there means it shifts to the right 1 unit of pi. And so I have it passing through that point. -1 pi is where the graph passes through.
negative 1 pi.
If that makes any sense at all.
Yeah, no. So in between your pi and 3 pi over 2, like, in between that.
Right.
So actually, start over. The next point, 3 pi over 2, is that also at the negative 1?
No, so that's where the graph goes up. That's the peak. I have it at 3 pi over 2. It passes through negative 1/2.
Okay, so how big is your period then?
So like well, the period is just pi. So I have if you can kind of see here, let me get it where you can see it. That's one period. This is here to pi is one period, and then pi to 2 pi is another period. So I have, because the graph shifts down 1, so it goes through this line here, and then it shifts to the right pi. So here I have like the origin of the graph here, passes through this point and it goes up. And then at 3 pi over 2, that's where it's peaking at 1/2, and then it comes back down, and at 2 pi it's back to this line here, and then it goes down and then back up, and so on and so forth.
Okay. So a period, from like what at least I understand, is a period is when it goes up, down, and then meets back. So it's like that weird S thing. It's like that's one period.
Oh, it's the whole thing. Let me see.
Yeah, because I noticed that you and I have both like the same starting point, but then yours is extended a little bit longer. Because from pi to 2 pi is one period, right? Because you're right, because it's like pi is one period. So then technically, if it would go up and then go all the way back down and then meet again in the middle at 2 pi. So it would shrink a little bit. So like I don't have all of it like you do. I just have the one. So it fits. I don't know if you can see that. It fits in between pi and 2 pi.
Okay, let me just a second.
I don't know if you can see that or not.
Not really.
Do you want to see it?
Oh, here, let me look. Okay, so that is the whole period. I think maybe that's where I got confused. Yeah, you're right. That is the whole period. Okay, so I need to redo mine and make sure that it doesn't do that again. So the whole period is pi, which means it's going to have a whole cycle in between. So that's where it's
pi and 2 pi. Yeah.
Pi and 2 pi. So let me show you again here.
Okay.
So right here, oh man, it's hard to see. That is a whole period. Can you see the units there too?
-1, and then that looks great.
Okay, cool. Man, good thing you know what you're doing.
I wish I had graph paper though. Like that's super convenient.
Well, that is nice. I used this notebook for another class last semester. It's nice to have it left over.
Yeah, seriously. Line paper is fun, but doesn't make everything look even.
Yeah. All right. Do you want to just go ahead and see if we can get the quiz done?
Yeah, that sounds good to me.
Okay.
Yes, I would love to write that up for us.
Okay, awesome. And I'll do it on some graph paper here too, just so we're on the same page, and then.
Okay, that sounds good to me. With the first one, thank goodness we don't have to, graph it. We just have to figure out what the equation is and the range.
Okay, so week 2 quiz. Let me see here. And we can use like our textbook and everything here.
Oh yeah, I'm sure we can.
Yeah, I think that's good. So.
Yeah.
All right.
Yep, you may only use your textbook notes and calculator.
Yeah. Okay.
No internet though.
No internet. All right. All right. So list the transformation made to the cosine function and write an equation of the form a cosine b times x minus c plus d, whose graph is the given cosine function. Also state the range. Okay. So it looks like, let's see here. I'm just going to kind of fill in pieces. Oh, I wish I had a light that worked. Oh, perfect. Okay. So I'm just going to fill in some pieces here. And it is a cosine of b times x minus c plus d. Okay, so it looks like this graph has shifted to the right, 3 pi over 2.
Mm-hmm.
It's a cosine function, and it's always on top there of.
Yeah.
Okay.
That sounds perfect.
So it would be, so far what we have is a cosine of b times x minus 3 pi over 2 plus d.
And it looks like it grew by 5, right? So wouldn't A be?
Yeah, so a should be 5.
Okay.
We have 5 cosine b x minus 3 pi over 2 plus d. It also looks like the graph is raised up by, like it went up 2, because I believe, yeah, because those
right.
Those 2 dots on the side are kind of like that middle line that runs through the graph, right?
Yeah.
Okay, so it's plus 2 at the end, right? Because plus makes it go up. So we have 5 cosine b x minus 3 pi over 2 plus 2. Okay, now we just need the stretch of it. So the period.
Okay.
Hold on, if the amplitude is not 5, I don't think. Because it moved up anyways.
Right, so it would be 3, right?
Yeah.
Okay, I am so glad you caught that.
That was close.
Yeah, seriously. 3, 3. Okay.
Okay. So the amplitude is 3. So we're just missing the B.
Yeah. As long as we can figure out what the period is, we can figure out B, but I wish he gave us a bigger graph. That'd be so much easier.
Yeah.
So this is just my guess. So even though cosine starts at a different point than sine, technically it's like the same S. It just part of the S is moved over. So I guess if we were to think about this, just pretend like this is a sine graph. If up and like one hill is 3 pi, then wouldn't 2 be 6 pi?
If one hill is 3 pi over 2.
Well, so you know how it goes like up and down and it reaches 3 pi?
Yeah.
So my guess is it's going to go down and up and reach 6 pi.
Oh.
So the period itself would be 6 pi. Obviously, we'd actually meet in the middle up top and then do the cosine. But it's technically the same thing because it's the same period. So at least it's my guess is that it would be at least the period is 6 pi. That's not what b is because we need to figure out how they got 6 pi. But
well, if the regular period is 2 pi, does that make b 3?
Well, I don't know, mate. Because I know, remember how the bigger the number, the smaller it is?
Right.
So it would technically be the opposite because it's like 2 pi over b. So 2 pi over b has to equal 6 pi, and we just gotta solve that. If 6 pi is the period.
So you said 2 pi over b equals 6 pi?
Yeah.
Okay. It's just pi over 3, I think.
Probably right. 6 pi times b.
Or 1, yes, so, or 1/3, I mean.
Because yeah, you're right. So it's like 1. Okay, so it's just 1. Oh, yeah, you're right. So it's just 1/3 if it's 6 pi.
Crap, that's wrong paper. Yeah, so it's 1/3.
Yeah, I think that's correct.
Okay. So the equation we have then is 3 cosine of 1/3 times x minus 3 pi over 2 plus 2. Does that sound right?
Yeah, that sounds perfect.
Okay, put it on there then.
Okay.
Awesome.
Okay, so 3 cosine 1/3 x minus 3 pi over 2 plus 2. We just did that. Yes, we did. Number 2, I am completely lost.
Okay, so I think it's kind of like those practice problems we did before, only just a little more complex. So sine of alpha, given that cosine of alpha is 2/5 and that sine of alpha is less than 0. So in terms of sine, cosine is, let me find it real quick. Oh, wait.
Yeah, how would you convert the 2/5? Like, how would you convert that into degrees? Is that like the times pi over 180 or?
Oh, good question. Let me look here. Oops. Wrong one, also wrong one. There it is. Cosine of alpha equals 2/5. And that sine is less than sine of alpha equals 0. So first, I think we have to know the relationship between sine and cosine. So let me look here. Let me find a little thing where it says. So sine of alpha equals y, and the cosine of alpha equals x. Man, okay. Let me think this through real quick. sine of alpha given that cosine of alpha equals 2/5. And the sine of alpha is less than 0. Can we use, no, we can't really use the unit circle on this one, can we?
Yeah, I don't know if it's in the textbook of how to convert real numbers into radians or degrees.
Hmm.
Yeah, maybe it's, I don't know, maybe it's under 5.1 or 5.2.
Well, there should be like a relationship like with these other ones, like how such and such like for example, for like how cotangent is, or tangent is the sine of alpha over the cosine of alpha.
Yeah.
Well, oh, hold on. I might just not know how to do this math.
Three radians. Converting from radians to degrees. Finding goals. Cool. Where's finding, finding real numbers is.
Do you know how to do the reverse of like a sine or a cosine? Like, so like if the cosine of alpha is 2/5, how to solve for alpha?
You're talking about like the.
I think it has something to do with like a natural log, like natural log of 0.4 is whatever.
I think I know what you're talking about. I just remember how to do that. But I think I know what you're talking about. It's a lot easier to find the data or whatever.
Yeah. Man, none of this is helpful. I feel like it's a lot simpler than what I'm trying to figure out.
I'm sure it is. I'm sure we're just really confused.
Gosh dang it.
How to turn that maybe into even a degree.
Well, it's not a radian. It's just 2/5. That's the.
Okay, so like 2/5 and pi/2, I think are both real numbers, but one is just.
Well, so that's the cosine of whatever radian. So that 2/5 would be, if we were to put it on this unit circle, would be in the coordinates, right?
Yeah.
So it would be the first number in one of those sets of coordinates, which means we need the cosine of that to make 2/5. And then let me figure this out. I'm just trying to think my way through it, because I feel like has something to do with the relationship between sine and cosine.
Relationship is.
Huh?
Is.
Sorry, I can't hear you.
Sorry. Do you know what the relationship is between sine and cosine?
No, I don't know that I can even find it in the textbook. I'm trying to find it. So the 2/5 is the x coordinate in whatever thing. Oh, wait. So the cosine of x equals y. Hold on, what does it say there in that? Hold on. Maybe this will work. So the sine of alpha equals y, and the cosine. Oh, that doesn't. Never mind. That doesn't work.
It's so hard.
So
I am trying what I found on page 341. I want to see if that helps at all. 2/5 times 180 degrees divided by pi. It's like 2/5 times 1 divided by pi.
Mm-hmm.
Which is a really weird number. So this would be like 22.91 degrees. But I don't know how that would help me find number. Have we done this before? Like, are we just forgetful, or?
I have no idea. Looking at some notes that I have. Hold on. Does it maybe have to do with like the Pythagorean stuff that we talked about yesterday or 2 days ago?
No, it might.
So I feel like that's not really part of this lesson though, but maybe it'll help me figure something out. So that says that sine squared of whatever plus cosine squared of whatever equals 1.
Actually, that might help.
So it's sine of x plus 2/5 squared equals 1. 4 over 25. Minus 4 over 5. 1 over 1. 1 over 1 minus 4 over 25. Or 25, sorry, 25 over 25 minus 4 over 25. Equals 21 over 25. Which does not reduce. Which means the sine of alpha equals 21 over 25. But it has to be less than 0. So that doesn't help either. I feel like...
Wait, so what?
Sorry?
What was the answer you got?
21 over 25. So...
Yeah, that's like...
Oh, wait.
Oh, you could just go back one, right?
Sorry?
So couldn't you just take away 25? Like, it would be like negative 4 over 25. It's the same thing. It's just all the way around 1.
Well, I think the problem with that is that's the sine squared of alpha. Hold on. The cosine squared. Cosine squared. So 2/5 squared is 4 over 25, right?
2/5 squared is 4 over squared.
I think so. Yes, it is. Unless we just take the square root of, hold on. So 21 over 25, the square root of that is square root of 21 over 5. And would it be negative 21? Negative the square root of 21 over 5?
Would it?
Well, so this is my reasoning here. So it says find the sine of alpha given that the cosine of alpha is 2/5 and that the sine of alpha is less than 0, right? So if you do this, this triangle thing, this Pythagorean theorem thing, that's the sine of alpha squared plus 2/5 squared, because 2/5 is the cosine of alpha squared, and that equals 1. And so if you square 2/5, you get 4 out of 25, right? And then you subtract 4 out of 25. and you get 21 out of 25. Does that sound right so far?
Yeah. So yeah. So what then?
So then you have to take the square root of both sides. So the sine of x squared is just the sine of x, or sine of alpha, whatever we're trying to find. Then the square root of 21 over 25 is the square root of 21 over 5. And can you simplify the square root of 21 anymore? I don't think you can.
No. Yeah, I don't think you can either.
So, and because it could be negative, like it could be positive or negative, it has to be negative because, does that make sense how you take the square root of something and it could be positive or negative? Like the square root of 16 could be 4 or negative 4.
Yeah.
So the answer could just be the square root negative square root of 21 over 5. It's sine of alpha.
Okay.
That is my best guess anyways.
That sounds like pretty good to me. So, okay, so tell me how to write this out.
Okay, so the sine squared of x plus the cosine squared of, well, alpha, not x, use the alpha instead of x, equals 1. We know that the cosine of alpha is 2/5, right? So the next part of the equation would be the sine squared of x plus 2/5 squared equals 1. And let me know when you're ready for me to give you the next part.
Okay, I am ready whenever you are.
Okay, so 2/5 squared would be 4 over 25, because you just square both the numerator and the denominator.
Okay.
Here, in fact, I'm going to write this out as well so that I have it straight as well. Give me just a second. So then sine squared alpha plus 4 out over 25 equals 1. Okay, then you subtract 4 out of 25 from 1.
Okay.
And you get the sine, oops. You get the sine squared alpha equals 1 minus 4 over 25, which is 21 over 25. So the sine squared of alpha equals 21 over 25.
And you get the square root of each side.
And you take the square root of each side, and what you're left with is sine of alpha equals the square root of 21 over the square root of 25, which is 5. So the square root of 21 over 5 is equal to sine of alpha.
Okay. That sounds great. Honestly, I think that's...
And it has, sorry, it's negative. It has to be negative because it says here in the problem that the sine of alpha is less than 0. So it's negative.
Oh, and I realized for number 1, we also need to state the range really quick.
Oh, yeah. Good idea.
5 to negative 3, right?
The range?
5 to negative 1. Or...
Here, let me... I forgot everything I read about the domain and range of the graphs here. So the domain for both sine and cosine functions is negative infinity and infinity, and the range for both functions is negative 1 and 1. When we combine these trigonomic functions with other functions that we have studied, determining domain and range can get interesting. For example, the range for f of x of natural log of sine is that. For some functions, the domain and range can only be approximated. Find the domain and range for each of the following functions. Use a calculator, table, or graph if necessary. So how do you find the range just by looking at the graph?
So the range is pretty much the lowest point it goes to. So it goes to 5, but we know that it moved up by 2. We know that the amplitude is 3. From the second, starting from 2, we'd go down 3, which is just negative 1, right? So it'd be like 5 to negative 1. is the range. Because the highest point is 5, the lowest point is -1.
Do you start with the lowest point, though, not the highest point?
Yeah, it has to be like -1, 5.
Okay, yeah, sounds good to me.
Okay. I am so glad I got number 2 because I didn't freaking understand. It's number 3.
Okay, so use the fundamental trigonometric identity to write two functions for cosine of alpha in terms of sine of alpha. Indicate which formula to use for a given value of alpha. Okay, you understand that one?
I don't know. Would one of them just be the formula you just used?
So yeah, I think what I use is just part of the fundamental trigonometric.
Yeah, so that would be one of them, right? One of the two.
Two functions for cosine of alpha in terms of sine alpha, which means two cosine functions. So y equals. Explain to me what you're thinking. I'm kind of lost again.
The only, I'm not. I mean, I really am not positive, but what I don't know. What I feel like it's asking is just oh gosh, like find two different. I'm not sure you say the word things that find cosine when you also have sine. Like that's how I interpret it, but
right. So is an answer like cosine of x equals 1 minus sine x? Is
would it
that
be squared or then would that be squared or no?
well no, because you square everything and the square root of 1 is just 1.
Okay, so cosine.
So I just wrote that, so cosine equals whatever. Is that what you're thinking of?
I think so. I mean, that's what crossed my mind.
Okay. Then let's do that. Cosine of x equals 1 minus sine x, because I mean you move everything and then you square root everything, and it's just you square root each of those terms, and it just comes out to be cosine of x equals 1 minus sine x.
Okay.
Or alpha, I guess. And then man, that's hard.
Okay, I think I have an idea for another one.
Okay.
This is just an idea because I don't freaking understand. But I know that tangent equals the sine over cosine, right?
Tangent
So
is sine over cosine, yes.
yeah, so then technically cosine would be sine over tangent.
Cosine would be sine over tangent?
Yeah.
Yeah. I believe that is correct.
That's just my only other guess.
No, that's yeah, so tangent of x equals sine of x over cosine of x, right? And then multiply the cosine of x, and then you divide by the tangent of x, which means cosine of x equals sine of x over tangent over x. Yeah.
Okay.
I think that's one that works.
So I will take a picture of this and send it to you. You can tell me if it looks good, and then I will upload it as a PDF.
Okay. It also says here, the last part of question 3, it says indicate which formula to use for a given value of alpha.
Okay. Oh, right. Right. Let me do that real quick.
I don't know what that means.
Sorry. Well, we at least know we can use 3 for any any real number, because that's what we just did for. Oh, sorry, I was not saying that correctly. We can use the first one, the code of alpha equals 1 minus sine alpha for any real number, because we use that to solve number 2. It was just a 2 over 5, not like a pi over 2.
Oh yeah, that's true. I guess that's the one.
Maybe for the other one, it's specifically for.
I don't know, because I feel like you could really use either one for any given value.
I mean, yeah. Technically it's true. Because all we're doing is, finding the opposite or the adjacent or the hypotenuse, which can be any number.
Yeah.
Could that? I don't know. Could that be the answer? It could be any real number can be used for any of these, or.
Yeah,
I have no idea.
You know what? Just indicate. I don't even know that we have to explain it. Just indicate that one of those equations is used. And if we get it wrong, then I guess we get it wrong, because I don't really understand that part of the question.
Okay. So just say the first one we could use for any given number of, or any value of alpha.
Mm-hmm. Yeah, because that's the one we used before to solve the equation.
Okay. Okay. Anything else that we need to do before I take a picture of this?
No, I think that's everything.
Okay.
So
I could take a picture, send it to you before I turn it in, and still upload the link of this.
Say that again.
I will send you a picture of this before I upload it, just so you can tell me if it looks okay or not.
Okay. Sounds good to me.
Okay, and I will upload this link as well. I'll give that to him.
Okay. Sounds good. Thank you.
Yeah, no problem. Thanks for sticking through.
Yeah, that was a long one.
Yeah, that definitely was a long one.
All right. I'll see you next time.
Yes. Bye, Tucker.
Bye.